Good afternoon, everybody. We are going to be covering notes 3.5 today, which is going to involve direct variation. Our learning target is I can write the equation to model direct variation and use the equation to solve problems, determine the reasonableness of solutions, and justify my thinking. So Unit 3, I don't know if I've mentioned this before in my other notes videos, but all of Unit 3 is about linear functions. And we talked earlier about three different types of linear functions. We had equations in slope-intercept form, in point-slope form, and in standard form. And we've talked, about how we can do stuff with those equations, right? We can graph from those equations. We can write equations from various information. Well, there is a specific type of linear equation called direct variation. And direct variation really isn't that different from other linear equations that we've looked at. There's only one kind of key difference between direct variation equations and other linear equations. Direct variation is still linear. It is still a linear function, but the way that we look at and use direct variation will differ from how we use and look at other linear equations. So the first vocabulary word that we have is direct variation. Our direct variation equation will look like this: y equals kx. It looks very similar to our slope-intercept form, which is y equals mx plus b, but instead of m, we are using the variable k. The other difference is when I'm looking at slope-intercept form, I'm going to have a b value, and that's my y-intercept, and it could be 5, it could be -10, it could be 3.2, it can be a whole bunch of different things. But if you look at our direct variation equation, there is nothing there. And the reason that there is nothing there is because the initial value, or b value, for direct variation equations is always going to be 0, always. Okay, so you can think of a direct variation equation in the form of y equals, I don't like how that looks, y equals mx plus 0, where m and k are the same thing. We won't use m though, we will use k specifically because that is what you use for direct variation. When we look at direct variation problems, instead of slope, we actually represent our m or our k value as something called a constant of variation. So that is going to be our k value, okay? It is this, okay? The constant of variation in a direct variation problem is like the slope or the m value of other linear equations. You're able to graph direct variation problems. They're going to start at the origin, and then you're going to use your constant of variation as your slope to do rise over run. So they are interchangeable. If you would prefer to use m, that's fine. And then the reason that direct variation equations are different than other linear equations is direct variation equations are proportional. They have proportional relationships. And you've learned about proportions before in middle school, but I am going to remind you that a proportion is an equation in which two ratios are also just fractions, are equal. So here's an example of a proportion. 1/2 is equal to 2/4, okay? You have a ratio, and they are set equal to each other. We've actually seen ratios in the course so far. If you think back to when we did slope and we were looking for a missing value at the very end of our slope notes, where you had one of your two coordinates was missing either the x value or the y value, and we would put something like this up here. That's kind of how we use proportions. We're going to do our cross multiplication just like we did, and that's going to help us know how one side of our proportion is equal to the other. Okay, but that's just what a proportion is. Boop. All right, so let's compare direct variation with slope-intercept form, okay? So slope-intercept form, the equation is y equals mx plus b. Our rate of change is m, and our y-intercept is b. And remember that your y-intercept in slope-intercept form can be a bunch of different values. It could be 0, but it's generally other things. Direct variation is y equals kx. My rate of change is k, and my y-intercept is always 0. It's not going to be anything else. We are going to graph this direct variation equation, and remember that since it's in the form y equals mx plus b, my b value is just 0. So what I can do is I can write down my slope, and I can write down my y-intercept. My y-intercept will always be the origin. No matter what with direct variation equations, it will always be the origin. And then your slope is your k value, or your m value. So we did this the other day, we start by plotting our y-intercept on our graph, which is 0, 0, so it's going to start at the origin. And then my slope is a positive 4 over a positive 3. And don't forget that you can write this as a negative 4 over negative 3. Okay? So I'm going to start with my positive 4 over positive 3. Positive 4 is my rise, so I'm going to go up 4. 1, 2, 3, 4. And then my positive 3 is my run, and positive 3 is to the right. So I'm going to go over 1, 2, 3. And there's a new coordinate. And then I can do the same thing with this slope by going down 4 and to the left 3. 1, 2, 3, 4. 1, 2, 3. And there I have my direct variation equation, and it must go through the origin. Other than that, they work the exact same as other slope-intercept equations. Okay, now we are going to solve and write direct variation equations by using proportions, depending on who your teacher is. Some teachers will use proportions, some teachers will use other methods of writing equations. I'm going to show you using proportions. However, if your teacher teaches you a different way, it's not wrong, it's just a different way. I used to teach this a different way. It just kind of depends on, you know, what we like, what we think works best for y'all. So if you are going online and you are looking at other people teaching direct variation, or your teacher teaches it a different way, it doesn't mean it's wrong. There are multiple ways to do this, but I'm going to use proportions. Direct variation problems have proportional relationships. So I'm going to use the word proportional. Okay, this means that we can set up and solve a proportion when dealing with direct variation problems. Okay, although we aren't going to do this with the first two examples here, when we get to direct variation problems, the problem itself might say that two things are directly proportional. So it even tells you in the directions oftentimes that your equations are proportional, or that the problem itself has a proportional relationship. Okay, so number one says set up and solve the proportions. If 5 apples cost $1.25, how much will 12 apples cost? Well, we know no matter what that apples aren't going to change price, okay? So what I do when I start this is I decide how I want to set up my ratios or my fractions. Do I want to do the number of apples over the total amount, or do I want to do the total amount over the number of apples? It really doesn't matter, but typically the first thing that I'm given is going to be what I put on top. So I'm going to do my ratios as number of apples over total cost. Okay, so when I set up my proportion, I'm going to follow that logic. So if 5 apples cost $1.25, how much will 12 apples cost? So I've set up my proportion. I've got the number of apples on top, and then I've got the total cost on bottom. I'm going to do this like I did the other day, where I multiply a numerator of one ratio by the denominator of the other, and then vice versa. So I'm going to start with the red one that I have there. I've got 12 times 1.25, and that is going to equal 5 times x. When I multiply that together, I have a calculator next to me, so I apologize if you can't see what I'm doing, but 12 times 1.25 gets me 15, and that's going to equal 5x. And then we divide both sides by 5, and you get that x is equal to 3. So what that means is, sorry, I can't write and talk at the same time. That means that 12 apples will cost $3 because the ratio will be the same as 5 apples costing $1.25. My second problem says if 20 cookies can be made from 2 cups of flour, how many cookies will 7 cups of flour make? So again, we have to choose, what do we want on top? I'm going to put the number of cookies on top. Number of cookies. And that is going to be over number of cups of flour. Okay, so if 20 cookies can be made from 2 cups of flour, how many cookies will 7 cups of flour make? So here's my proportion. I've got my proportions being multiplied across using cross multiplication this way. So that's going to be 2 times x equals 7 times 20. 2x equals 140. we divide both sides by 2, and we know that x will equal 70 cookies. And that is how we will set up and solve proportions, okay? So we're going to use that logic when we set up and write and solve direct variation problems, okay? So let's take a look at number 1. It says the variables y and x vary directly. So direct variation equations will always tell you that they're direct variation equations by using something like varies directly, or let's see, there's another one. Over here on number 3, it says they are directly proportional. So on all of these questions, it has the word direct or directly. If you see that, you automatically think to yourself, it is direct variation, it is nothing else, okay? But I'm going to look at number 1. So it says the variables y and x vary directly. Y is 12 when x is 3. Write the direct variation equation that relates x and y, and then we're going to use the equation that we get in part A to help us solve part B. So if you look at this problem, you've got y is 12 when x is 3. So we're going to do one of our variables on top and one of our variables on bottom. You do not get to choose when you do direct variation problems, okay? If you know for a fact you've got a direct variation problem, you must set up your proportion by doing y divided by x. You have to. You can't do x divided by y. You've got to do y divided by x, okay? So I'm supposed to do y over x. That means I'm going to do 12 over 3. And I'm going to go ahead and just simplify that, and that's going to be 4. So my direct variation equation is going to be y equals 4x. Now, I actually don't need to set up a proportion for this. Maybe later, but not right now. And then what I'm going to do is I'm going to use that equation to help me with part B. It says find the value of y when x equals 8. So if I know that my direct variation equation is y equals 4x, and my x is supposed to be 8, I'm just going to plug that in here. So y equals 4 times 8, and 8 times 4 is 32. So I know that my final answer will be that y is 32. Now, I can show you kind of what this looks like whenever we use proportions. It told me at the beginning that 12 over 3 was my proportion that I needed to set up. And I can set that equal to, it tells me find the value of y when x is 8. So here I've set up a proportion, okay, using both of these pieces of information here. And then I can cross multiply. 3y equals 12 times 8. I don't know what that is. 12 times 8 is 96. I always want to say it's 72. And then when you divide both sides by 3, 96 divided by 3 still gets me 32. So no matter what way I chose to do this question, I still end up with y being 32. Let's look at example 2. It says the variables p and l vary directly. P is 18 when L is 9. So this question actually does not give us our variables x and y. We're using P and L. So the rule is whatever they give you first goes on top, okay? So we are going to do P over L. So we have P over L. It tells me that P is 18 when L is 9. So when I simplify that, I get 2. So my equation, my direct variation equation will be P equals 2L. And then I'm going to use that to help me with this one right here. It says find the value of L when P is negative 6. So I'm supposed to be using P equals 2L. It tells me that P is negative 6. So I got to come over here and actually put negative 6 there. Divide both sides by 2. And you get that L is equal to negative 3. Now again, you can set up a proportion if you would like to, once you know both pieces of information here. You can do 18 divided by 9, that comes from part A. And then part B says find the value of L, so L's on bottom, when P is negative 6. So you would do 9 times negative 6 equals 18 times L. 9 times negative 6 is negative 54. That equals 18L. Divide both sides by 18, and you get that L is equal to negative 3, which is what we got in part B. Isn't that cool? You might not think it's cool, but I think it's cool. Okay, let's look at number 3. The variables y and x are directly proportional, and y is 2 when x is 10. So we have to do y over x. That's going to be 2 over 10. And that's actually going to be 1/5, which is kind of gross, but that's okay. So we have y equals 1/5 x. There's my equation that relates x and y. Now I'm going to use that equation to help me down here. It says find the value of y when x is -4. So when I do 1/5 times -4, I actually get -4/5 as my final answer. You can plug that in the calculator if you would like, but that is for sure what you're going to get. Okay. Number 4 just wants us to write an equation. It doesn't want us to use the equation to solve, but it says the height h of a board varies directly. Hey, varies directly with its weight W. An 11-foot tall board weighs 242 pounds. Write an equation that relates h to W. So the first variable that it gave me was h, so I'm going to do h divided by L. Okay? Now, it tells me that an 11-foot tall board, that is height, weighs, whoopsies, I put L, but I meant to put W. I'm a silly goose. Okay, an 11-foot tall board weighs 242 pounds. Write an equation that relates h to W. So what I'm going to do is I'm going to pull up my calculator here so I can, let's go back. So I can show you how to do this in the calculator if you need to. Also, this is a really nice app if you do not have a TI-84 at home and you don't necessarily want to use Desmos. So in my calculator, I'm going to do 11 divided by 242, and I hit enter. And it's going to give me this decimal. And decimals are icky boo boo kitty. We don't like them. So what we're going to do instead is look at the left side of your calculator. You've got y equals, you've got the blue button that says second, you've got the green button that says alpha, and then the number right below it literally says math on it. You're going to click math, and you're not going to touch or scroll or do anything. You're just going to hit enter once, which this is telling you that they're going to take your answer and change it to a fraction. That's what A and S arrow frac means. They're going to take your answer that you just got and change it. That's what the triangle means. Change it into a fraction. And you hit enter one more time, and it gets you a simplified fraction of 1/22. Now, that is not an equation that relates h to W. I have to say h is equal to 1/22 times W. And now I have my equation that relates h and W. Goodbye. Go away. Thank you. Okay, I'm going to need that again here in a second. So that is how you write a direct variation equation from word problems. Now, the last thing that we have to talk about with direct variation equations is determining whether or not a table represents direct variation. So we cannot look at tables like we have been looking at tables. It's not enough for us to check our y values, like y2 minus y1 over x2 minus x1, because we have to make sure that our tables are truly representing proportional relationships. And you will not know that your table represents a proportional relationship by doing y2 minus y1 over x2 minus x1, because you may get something that is a consistent rate of change, but you must have your table go through the origin at 0, 0. Now, sometimes your table, like if you look here, this table and this table shows that your equation goes through the origin, but the other two tables do not. But that doesn't necessarily mean that they are not direct variation. We have to check. So just like what we did up here, where we did everything was y divided by x, that's what we're going to do with this table, with these tables. Okay, so it tells us up here some steps for us to help us. It says, first determine if your table represents direct variation by dividing your y values by your x values. Okay, this is going to end up being your k value, or your constants of variation, and that's what we talked about earlier on in the top part of our notes. Step 2 says, if all divided values are the same, then your table does represent direct variation, and you can write the equation of the table. If it does, you're going to plug your k value that you got into the direct variation equation. Okay, so what we're going to do is we are going to take each one of our y values and divide them by our x value. So I'm going to do 30 divided by -0.2. And I'm going to do that across my entire table. And I will show you with that calculator again. Give me a calculator. Zoop. Scooch. Okay. So I'm going to start by doing 30 divided by -0.2, and I get -150. And I always write that number at the top of my table since I'm going top to bottom. I'm doing y divided by x and then putting whatever I get at the top. Okay, next, 300 divided by -2. That's also -150. So far, so good. -75 divided by 0.5. negative 150. This is good because remember that I want this number at the top, that k value, to be the same all the way across. And then negative 6 divided by 0.04 also gets me negative 150. So the question is, does this represent direct variation? We're going to say yes, it does. And the way that we write our equation is, direct variation equations are in the form y equals kx. These values up here are my k values, so my equation will be y equals negative 150x. And that's all you have to do. So let's take a look at our second table. I'm going to do my y divided by x. Okay, so we've got negative 5 divided by negative 60, and that gets me that. I'm going to do math enter to change it to a fraction. So that is 1/12. 3 divided by 36. That looks just like the same decimal I got earlier. Okay. Then we're going to do 0 divided by 0. Uh-oh. When I do 0 divided by 0, I'm going to get an error message on my calculator. Your calculator will say error, cannot divide by 0 or something like that. This one says 0 divided by 0 is not a number. So that's okay, because remember that direct variation equation should pass through the origin, and 0, 0 is the origin. So I can just go ahead and say that that's good. It's okay that it's not 1/12. It will never be 1/12 if it's the origin. So as long as you have a 0 over 0, just check it, like that's good, but you still got to check everything else. So I'm going to now do 11 divided by 132. That looks like the same decimal. Yes. Okay, so even though we had that one little snafu with 0 over 0, we still do have a direct variation equation, and your equation will be y equals 1/12x. Okay, next, let's do this guy. All right, so I'm going to do 9 divided by 0.4, and that is 22.5. I'll just leave that as 22.5. That's an okay decimal. 50 divided by 3 is, 16.6 repeating. I don't have to go any further than this. If the numbers at the top when you divide are not the same, you do not have a direct variation equation or a direct variation table. So this is not direct variation, and if you put no for direct variation, there is no equation, so don't write it, okay? Just leave it alone. Just put none, put NA, whatever you want, but do not put an equation because there is not an equation. Okay. Let's check this last table. I'm going to go ahead and check this, that's good, because I know that 0, 0 will not get me what I want on my calculator. But again, just because 0, 0 doesn't mean that you automatically have a direct variation equation. You must check all of the y divided by x's. All right, so I'm going to do 2 divided by 8, which gets me, that's 1/4 as a fraction. You can do math, enter. Okay, let's do negative 2 divided by negative 8. That also gets me 1/4. And then negative 6 divided by negative 16, ooh, that gets me 3/8. So it was looking good for a while, but then all of a sudden my very last problem, my very last y divided by x gave me something that was not 1/4. So this is actually not a direct variation equation. So there will not be a direct variation equation. All right, y'all, that is pretty much everything that you need to know about direct variation problems. If you have any questions, please go talk to your teacher during their normally scheduled